Our world runs on this massive hidden network of pipes. They bring water to your tap, fuel to a ship's engine, you name it. But have you ever stopped to think about how we connect them all, safely and reliably? Well, today, we're going to dive into the brilliant engineering of the humble pipe coupling, a piece of tech that is way more advanced than you might think.
Okay, just imagine this for a second. A critical pipeline in a power plant or maybe on an oil rig springs a major leak. You can't just shut it down. That would cost millions, cause total chaos. So what do? This is exactly the kind of high-stakes problem that forces engineering to get really, really creative.
For the longest time, the go-to answer was just welding. But, welding is slow, it's a huge fire hazard, and it creates this totally rigid joint that just can't handle any kind of vibration. Modern pipe couplings, though, they are an absolute game changer. They're fast, they're incredibly safe to install, and they are literally designed to absorb movement.
So what even is a coupling, really? Well, at its heart, it's basically a super sophisticated, high-tech clamp. But the real genius is in its simplicity and the incredible materials they use. Let's break it down.
A coupling's power really comes down to three parts working together perfectly. First up, you've got the casing. That's the strong stainless steel shell. It provides all the muscle. Inside that, you have the gasket, which is the all-important seal. It's made of specialized rubber that makes sure the fit is completely leak-proof. And finally, the secret weapon, the grip ring. It's this ring of super sharp teeth that physically bites into the pipe, making sure it can never, ever pull out. So you've got muscle, a seal, and teeth. It's a simple idea, but unbelievably effective.
But what happens when things aren't just sitting still? In ships, factories, power plants, pipes are constantly vibrating and moving. And that rigid joint from welding, it would just crack under that kind of pressure. And this presents the first big engineering challenge.
The official terms for this are expansion and contraction movement and angular deflection. So what does that actually mean? Well, in plain English, it just means pipes get longer and shorter when the temperature changes, and they also vibrate and shift off center. You need a connector that can actually move with them.
And the solution is the multi-flex type coupling. The whole design is based on this idea called non-axial restraint. What that means is, unlike that grip type we just saw, this one doesn't bite down and lock the pipes in place. Instead, it creates this incredibly powerful seal that actually allows the pipes to shift around, to expand and contract inside the casing, and it does all of that without ever leaking. It's a coupling that's truly built for a world in motion.
All right, so this brings us right back to that crazy problem we started with. How do you fix that critical leak that you absolutely cannot shut down? How do you perform emergency surgery on a live, high-pressure pipeline when you can't just slide a coupling over the ends? You see, the goal here is to fix everything from a bad well to actual cracks, and to do it, as the engineers say, with minimal downtime. Every single second a system is offline costs a fortune and creates more risk. The repair has to be lightning fast, and it has to happen while that pipe is still active. And the solution for this is it's brilliant. It's called the repair clamp hinge type, or RCH for short. And the big innovation is right there in the name. It's a coupling that is literally split in half and put on a hinge. Because of this split body design, an engineer can open this clamp up like a clamshell, wrap it directly around the leaking part of the pipe, and just bolt it shut. The gasket on the inside seals the leak instantly, and the whole system never had to be turned off. It's just an incredibly elegant solution to a really, really messy problem. Okay, now we're getting into the really dramatic stuff. These couplings aren't just for regular buildings. They are pushed to the absolute limit in some of the most extreme environments you could imagine, both on and under the Earth. I want you to picture this. A fire breaks out deep in the engine room of a massive cargo ship. The firefighting lines, the ones carrying all the water to put out the flames, they run right through the middle of the fire. If those pipe connections fail, the whole ship is lost. So to handle this insane situation, engineers developed the Fire Protect Cover, or FPC, grip-type coupling. It's specially designed with this protective outer shell that shields all the internal parts, making sure that seal stays completely intact, even when it's literally engulfed in flames. So how well does it work? Get this, it's been officially tested to withstand 800 degrees Celsius. That is nearly 1,500 degrees Fahrenheit for a full 30 minutes, all while holding pressure. That 30 minutes is the difference between a close call and a complete catastrophe at sea. Okay, let's go from extreme heat to extreme pressure and just unbelievable scale. Let's go to the bottom of the ocean. How in the world do you connect gigantic pipelines deep underwater, where welding is totally impossible and the pressure is trying to crush everything? For a job like that, you have to bring in the heavyweights, the wide, large type couplings. These things are just monstrous versions of the couplings we've been looking at, engineered to handle incredible pressures and connect pipes on a truly massive scale for things like deep seawater intakes.
And when I say massive, I am not kidding. They have built couplings with a diameter of 3,120 millimeters. That's over 3 meters, more than 10 feet across. A single coupling big enough for a person to walk right through, designed to be installed on the ocean floor. It's just mind-boggling. So after seeing all of that, it's pretty clear, right? The pipe coupling isn't just some simple clamp. It's a masterpiece of precision engineering, a real unsung hero that quietly and reliably holds our entire world together. And they are literally everywhere, in shipbuilding, in the water and sewage systems that serve your city, in all kinds of power plants, nuclear, thermal, you name it, gas lines, industrial factories, even deep in subways and other underground structures. They are the invisible links in countless systems we all rely on every single day. And this proves they aren't just a replacement for welding, they are a massive upgrade. Couplings can reduce vibrations and noise by over 60%, and they're 30% lighter than old-fashioned connections. They make our systems safer, quieter, lighter, and so much faster to build and to repair. So while we're all just going about our lives, these incredible little devices are working in the background, solving incredible challenges from extreme heat to the crushing depths of the ocean. It really just leaves you with one final question. What other invisible inventions are out there, silently and brilliantly holding our world together?